Hello, I am Zain Yusuf, and I will teach you some important tricks, some concepts, and appropriate way to approach a complex fundamental programming problems. Uh, for that, I have an example to illustrate some fundamental concepts. You are asked to write a C++ program in which a user wants to convert the binary numbers to decimal. So see the highlighted area, the binary numbers we are talking about. So it must accept the valid digit. For example, 3 is not a valid binary digit. So keep these things in mind. And by the way, the user should be allowed to input the digits of binary in a reversed order. For example, at the time program is running and it is asking the user, okay, enter the digit. User enter the digit, the least significant. It means from the right side. Okay? And the input will terminate on -1 if is user keeps on entering the values, and the program terminates when the user enters -1, and the -1 will not be the part of binary input because it is not a valid binary digit. So the final task is to print the decimal number that you have converted, and make sure you are not using an array, nor you are using the any other library. You are taking any other library help, including some sort of CMath, etc. So except fundamental iostream main header file. Before we go to solve the problem, we need some prerequisites, some concepts required at this level. Cumulative sum. As you know, if you are not familiar with this sum, for example, how to update, but you do it more frequently. For example, sometimes you say I is equal to I plus 1, I plus plus. So this sort of is basically cumulative sum. We keep on updating a variable. I have an example, sum is equal to sum plus number. The sum variable on the right side, it contains the previous value, and the number contains another value. If we combine it and then we put it in the sum, in the next loop, the sum will have previous value and the number have the previous value. So what we are doing, we are just putting the previous value into the new variable. So it is growing cumulatively. And the second concept here is breaking at rogue value. If you have to break somewhere conditionally and you don't know how many times you need to run your loop, at that time we use a rogue value. Rogue value means sometimes we use -1, as it is illustrated in the previous example we are trying to solve. It is instructed that you should use -1. -1 is rogue value. As soon as you will put -1, the program should terminate that. Okay. I have illustrated it here in an example. While var is not equal to rogue, so as soon as it remains true, the while body will always run. And I have few assumptions. Possibly you are familiar with basic commands, loops, while, and input output commands. All right, so for example, here if we want to compute the binary of 1010, and we want to convert it into decimal, finally we need to go through some steps, and the interface of our program should be like this. It asks, okay, enter a digit, first digit. So user enters the first digit 0, and if you see, as I have already told you, that we should enter a number from the right side. So if you go here, okay, 1 0 and 0, so you must be inserting a number from the right hand side. So this is least significant. You must not be going from left to right, but it is right to left. All right, so it asks again, okay, enter the second digit. So user enters 1. All right, so third 0 1, and to terminate the program we should enter -1. So it is terminated. The decimal value is 10, and that is, I believe, correct. So let us see how mathematically we solve this problem. We do it, we have done in 8th grade, and in some schools even 3rd or 4th grade people do this way. All right, if you see in the first row 1010, this is our binary, and what we want to convert it into decimal. So in the second value, the second row, we say 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3, and so on. Okay, in the third row, what we do, we have to uh, 2 to the power 0 multiplied by 0, and 2 to the power 1 multiplied by 1, and 2 to the power 2 multiplied by 0, and then sum up all these terms and it becomes 10. If you try to compute it, pause the video and try it. You will get the result 10. So similarly, we will use the same way here. We have basically computed this way. Okay. Here is pseudocode version 1. I have also version 2. There we will have more refinement, but here for the time being decimal is equal to 0, power 0, digits, etc. And here is some we are breaking the loop at -1. At -1 we directly go print the decimal. Okay, and this is the basic definition. Decimal is equal to 2 to the power multiply digit that we used in the previous here. Okay, all right, and power becomes 1 plus 1. But this code is unfortunately not close to the machine. It is more abstract, and we will try to refine it in the pseudocode version 2 here, because we are not expected to use 2 to the power, because for that we will have to import some functions from other libraries that we are not expected to use. So we have another methodology. I have removed the power, and instead I place the place value. For example, your place value for 2 to the power 0 is 1, and 2 to the power 2 is 2. So similarly here, if you see place is 0, then place becomes place multiply 2. 2 ones are 2, it becomes 2, and it is assigned to the new place value, and every time it is multiplied by 2, 2 to the power 4, then 8, and so on. So it is working fine here, and then we multiply by the digit here. So if you pause the video and see the code, and you may type it on your own editor and try to compile it, then try to grasp it, so obviously it will run. Okay, so let's move to C++ real code that we are required to write. First of all, we are including some fundamental preprocessor directives. We are declaring some variables. Okay, and this code looks same to our pseudocode, but there's a little bit syntax difference. Okay, and let me show you some write on I have recorded in my table. So if you see, I have digit, place, decimal, counter, while, output. So these red values shows that what I have already assigned before running the actual program. So 0, 1 counter, if you see in the first row. Okay, so these values have been assigned here, and the user enters the value of 0, and the place is since 1, decimal is so far as 0, and the counter has become 2, and it is still true. I have omitted these values, true, true, true. It should be written there 0, 1, 0, 1. As soon as the user enters the -1, so output is 10. So you can try by your own self, but let's move to live coding. In live coding, I have to first of all clear one concept, terminating on -1, because many people have problem. They do not know how to terminate it. They write in a while loop, but while loop runs infinitely, and your program, your computer is halted, it remains in an undefined state, then obviously you have to shut down manually. Okay, for that, let me show you some minimalistic code. All right, let me first of all comment it out. Control Shift C. All right. Yes. In this code, I want to tell you that how to terminate at a rogue value. For example, we have rogue value -1. Digit is not equal to -1. So as soon as digit becomes -1, so while loop exits. So one thing you need to remember, before while, digit should have some sort of value. And in the loop, digit must be updating itself. So while has three conditions: one before while is running, and one in the logical expression, and then one in its body. So if you are using while, you are expected to write at three places: before, at logical testing, and in the body. If you have omitted one of them, it means probably your loop will is non-stop. Okay, so let me run it. Okay, it asks 0, 1, 2, 3, okay, 9. But what we have put 9, it is accepting, it is taking as binary valid digit. No, it should not be taking that, but we will fix it. For the time being, let me put -1. Oh, it stops. So it's working fine. In next code, let me comment it. Control C. All right. So I have another improved version. Control Shift X. Here, what I have to do now, it should not be accepting the number greater than 1 and less than 0, because those numbers are out of range. Let me try it. Okay, 0, it says valid binary digit, hurrah. 1, yes, working fine. If I say -3, no, not a valid binary digit. So for example 9, similarly. Okay, so let me terminate whether it's working or not. -1. Oh yeah, it worked. So we have improved somewhat here. Let me comment it out again, and let me see what we want to do now. Okay, so what we have learned that how to terminate at -1. We have also learned that how to accept valid digit. So you can see the logic of the code that I have used. I have used a selection command. If code is in the range greater than 0 and less than 1, less than or equal to 1, it means it is valid digit. Okay, so the third one is complete program. So we will obviously be running the complete code that we promised to write. So here goes our final code. Control Shift X. Hope it is visible. Let me fix it. Okay, now it's visible. Using namespace, STD, etc. You have all these variables that I told you in the slides, decimal, so etc. There's nothing special. There's only a little bit modification that how we are updating the decimal value here. If digit is greater than or equal to 0, digit is less than 1, it means it's a binary digit, and we must be performing some actions here. So place is equal to place. So there's nothing something, but it has a little bit improvements in it. Let me say it's 0. It says, but make sure you are putting number in reverse order. So 0, 1, 0, and 1. So it says, and the fifth one is -1, so it's 10. All right, so 10 answer is correct. Yeah. Okay, so we have completed terminating on -1. We have accepted the valid digit, and we have completed the whole program. And that's it. Thank you for your watching.